Welcome back to the online classes. This is Zafarullah Mangi from the Department of Mathematics. We are going to start the topic some important limits for class second year. We have already discussed about the sequence and limit of the sequence, and now we start some important limits. So first of all, number one condition is that consider the sequence 1, 1 upon 2, 1 upon 3, 1 upon 4, 1 upon 5 up to so on. This sequence going to the infinite digits. So here one thing is, here in this sequence there is no any number in denominator, so it must be takes only one digit. One always takes in denominator digit 1. So if we write 1 upon 1, or you can write here 1, it must be same. So this sequence of the general term, this sequence shows the general term of an is equals to 1 upon n, because n belongs to the natural numbers. In sequence system, n always belongs to the natural numbers. If we take, let's suppose, if we say that there is 1 and in upon it takes 1, then what will be the, is this sequence is satisfied or not to this sequence? This general term is satisfied this sequence or not? So first we take the natural numbers start from 1. If we put here n is equals to 1, then 1 upon 1 is represent 1. Let's suppose, I explain it. Let's suppose this sequence, this general term a n is equals to 1 upon n. Let's suppose we put here n is equals to 1, then first term a1 n takes 1 upon 1, which will be equals to 1. Here the first term it represent only 1 upon 1 is equals to 1. So first term is here. Now second term 1 upon 2. If we take n is equals to 2, then what will be the result is, here n put 2 and here is 2, then 1 upon 2 is equals to 1 upon 2. So when we put here n is equals to 2, then the second term of this sequence represent 1 upon 2. Again same here, if we put here 3, then third term is 1 upon 3. If we put here 4, then 1 upon 4, fourth term is 1 upon 4, 5 term is 1 upon 5, and infinity term is equals to 0. It must reduce or converges from higher position to the lower position. Okay, and n always belongs to the natural numbers. So there is an important property, that x comma y belongs to R. X and y both are belongs to the real numbers. R represent the real numbers, and this symbol represent and. It must shows that x and y belongs to the real number, and x is positive. X is positive number. X always be in positive number, but y sometimes, or you can say that positive, sometimes you can say that negative, or sometimes it must equals to the 0. So y is any number which belongs to the real number, but x must be positive number but not negative number. Okay, so here x represent positive number, x represent positive number, then there is a natural number n, there is a natural number. This is positive real number, and here we applying here n is a natural number. I have already told you here in general term. So n is a natural number such that y less than nx. y less than nx. So this property, how can we solve it in this property? Let's suppose if we say that y less than nx, here any number you can put here in the place of n and n in the place of x, and y, let's suppose y is equals to 2 or 1. If we put here n is equals to 3 and x is equals to 4, then what will be the result? Is 2 less than 3 multiplied 4 is equals to 12. 2 less than 12. Actually this property represent the less than property. Okay, y less than nx. N and x are both are positive numbers, where n belongs to the natural number which start from 1 positive, and x belongs to the positive real number which are belongs to the real number. But in x always takes place the positive real number, okay, from positive real number, and y sometimes positive, sometimes negative, sometimes 0. So this property must be lying on this position. So here let this symbol represent epsilon. This symbol epsilon. Epsilon. This symbol represent epsilon, which means any positive value which is smallest or approximate value. Let epsilon be a positive real number, then we can find positive integer. n1 such that we can find positive integer n1. Here if we put here in the place of y we put here 1 less than n is remaining same, and x takes place the epsilon. So we put here in the place of y is equals to 1 and in the place of x is equals to epsilon, and n, let's suppose, gives the name n1, or n is equals to n1. Let's suppose. Now here 1 less than n1 epsilon multiplied by epsilon. Here n1 multiplied by epsilon, when it convert or it goes to another side, it must be divided to the other form, to the another number. So here n1 is multiplied, and now here n1 is divided to the 1. Now 1 upon n1 less than epsilon. 1 upon n1 less than epsilon. Okay. Here for all values n greater than n1. For all values n greater than n1. It means that n1 is a positive integer. Okay. Now here in this sense, in this form, n greater than n1, then let's suppose 2 is greater than 3. Let's suppose 3 is greater than 2. 3 is greater than 2. If we put here 1 upon 3 greater than 1 upon 2. Is this right or wrong? Is this right or wrong? Let's suppose if we say that 3 greater than 2, then 1 upon 3 greater than 2, is this right or wrong? Right or wrong? So you can say that when we divide 3 by 1, When we divide 3 by 1, then it must takes place, the result is 0.333. If we divide 2 with 1, then it must be takes 0.5. Then what will be the result is? Then we can say that 1 upon n less than 1 upon n1.